Welcome to the latest podcast from Exeter Expertise. Today we are talking to Saeema Ahmed-Kristensen from the Index Centre at the University of Exeter Business School. We're going to be talking about her work in the area of data-driven design, in particular that of products. Saeema, great to be talking to you this morning. Thanks very much for talking to us. Can I start by asking you, for the benefit of our listeners, how would you define data-driven design?
Thank you, Toby. For data-driven design, for us, is the move with disruptive technologies. So there's availability of data, there's AI techniques, and there's new disruptive technologies which are changing the way that we consider what a physical product is. So through data-driven design, we have opportunities to better understand the consumer, the users of the products, and use this understanding to inform the design of the products, whether customized, how they're manufactured, but also to support those who are designing, particularly in products such as aerospace, where there's complexity that's beyond any single individual, or products where there's a lifetime of knowledge. So, for example, on oil rigs or aeroplanes or automobiles, they last for many, many years. And having data to understand how these products behave are very important to understanding how you can redesign them to be more sustainable or to have a better experience.
Can I ask, I'm guessing that we've always had some data about products going back a few years. My assumption is that because of digital technology, the amount of data that we have now is exponentially increased. Is that correct?
Yes, I'd say that's correct, and also not completely correct as well. With Industry 4.0, there is certainly a drive of sensor technology and the availability of data. There's a huge amount of more data than there were 10 or 20 years ago. And those sorts of data enable things like predictive maintenance, so understanding how a part's going to fail before it fails, for example. Where we don't have data is understanding experiences of users. And those are also really important data.
What motivated you to get involved in this area? Could you tell me a bit about your background?
Yes, I'm originally a product designer and then an engineering designer from Cambridge University. And I've always worked in design and understanding both how you support decision making for engineering designers and their teams, and then how you also model products in order to enable better designs, to customize their design. Now, over time, so since starting that work, the things that have changed are the ones that we've touched on. There's been digital technology, there's availability of data, there's AI, so there's more opportunities which result in a changing nature of manufacturing. So these products that were purely physical don't any longer need to be purely physical. So they can be informed by data, but we could also use data to support the decision making. So it's a natural transition of my original work to understanding the influence of disruptive technologies. When I started my research, it was observing engineers and understanding how they make decisions and using those cognitive models to inform decision making. But now we have data that could also support us in the data-driven decision making, for example.
Taking what you've said so far, how well is data being used at the moment? I guess what I'm after is how much more potential is there to really improve the process of design, as you say, for manufacturers and consumers and designers?
Yes, I think there's actually huge potential. There's data scientists and there's work of understanding how you process available data. Yet in terms of understanding data-driven decision-making, so how you reduce the complexity and understand how a product's going to behave and bring that knowledge to engineers or engineering designers, or how you customize products so they're better for comfort. So an example is some work we've done with headset companies, looking at how many different variants are needed in order to maximize comfort. And then we've extended that work to understand orthosis design. So how do you support patients in maximizing their comfort and reducing surgical intervention by customizing the product? For those areas, the data is not freely available. So there's a huge amount of research that's needed to understand which data is relevant for that product context and drawing that model together. That combined with what is available, the data techniques of analysis, enable us to do a lot more research. And I think there's huge potential. There's directions towards digital twins, for which understanding data and the context of how you draw that data towards the products or the people that need to make decisions around it. That's a research area which is largely untouched. We're building knowledge, but we've got a huge way to go in that area.
Can you talk to me about some of the various benefits? I mean, you mentioned some there in terms of the kind of personalization of products such as headsets, but I guess I'm interested in both the benefits for the individual consumers, but also the more macro benefits, particularly around that of waste and being more environmentally friendly. I mean, how much can data-driven design help in that area, for example?
Yeah, so if we just go back to the example of personalization. So one way to do personalization is you involve the user to design a bespoke product. So it's one product for one person. Using data-driven design, it enables you to create variants rather than one. So it's sort of personalization. The user may think that it's been personalized, but it actually hasn't been personalized for one person. But we can group people. Now, by doing that, for example, understanding why people buy products and variants and products, we can build products and design products that last longer through understanding what we call product attachment, creating an attachment with your product so people are less likely to throw it away. And effectively, this is extending the life of the product. But also from the manufacturer's point of view, it's reducing the number of different types of products that need to be made. So if you want to maximize comfort, understanding how many different variants are needed, enable you to do this with less resources, less materials, and hopefully extended product lives. You've also got opportunities the other way around to look at predictive maintenance. So extending the life of your products, which aren't necessarily for consumers, but business to business products like aero engine examples that I gave, or oil rigs, enable you to prevent failure and prevent waste in that systems.
If someone is in an organisation who is responsible for design or manufacturing and they're listening to this, what are some of the practical implications that you would say that they need to start thinking about in order to better use data to design products and services?
I think there's three sort of main problems to consider. One is lifetime and life cycle of products. So whether it's how a product, which is an engineering product, behaves for 20, 30 years, and how that service data can be used to redesign products to be more effective and reduce failure. The second is whether they're consumer products or healthcare products, where comfort or the experience is not a frivolous activity. It's really important for the patient's well-being. And the third is how can you reduce complexity in the process itself for the engineering designers. So those are the three aspects of complexity where we've got an opportunity to think about what is possible. So I would say to manufacturers to think about those three areas and think about what we can do and what sort of models that we can build in order to create tools that are data-driven design, data-driven innovation, or data-driven decision-making. And the other thing I would say is, as we go through Industry 4.0, what is a product is changing. So it's not just one product. They can become smart products and then go all the way through to what is referred to as systems of systems. So effectively, groups of products working together, maybe looking at a sustainable case, for example, the farm to fork example that's often given. And that requires experiences of users understanding how to motivate users to work with data that is across different industries for the benefit of all. And that's a complex model. So understanding how that data is stored, how to motivate all the different stakeholders in that loop to work together to store data, and how that data is actually effectively going to be used for decision making are all future problems that we need to start dealing with now in order to change our futures.
Simon, that's a fantastic point to end our conversation on. Thank you very much for speaking to Exeter Expertise. Thank you.
Thank you.